Hi everybody, welcome to ABE 85. So all of chapter 1 that we're doing should be a review for you. If it's not, you might want to either come ask me for help or think about possibly taking ABE 84 to catch up on some skills first before you take this class. So if you go through some of this and you see that it's not really a review or you're struggling through the material, come talk to me and we can probably discuss a better option for you. Okay, so this page right here is really just talking about the number line. So you've got your larger numbers headed to the right. And your smaller numbers are going to the left. So our number system is called the place value system. And so the place values are broken up into threes, so groups of threes. So your ones are right there, and those include the hundreds, the tens, and the ones. Your thousands are here, 100,000s, 10,000s, thousands, millions, and look at that, same sort of pattern, 100 millions, 10 millions, millions, billions, broken up the same way, trillions, broken up the same way. All right, so whenever we are asking ourselves how to say a number, you only say the period that it belongs in. So in this case, this number right here. And you never say 4 ones. You never say that. Okay, so we would say 5,278,194. You wouldn't say 194 ones, okay? So 5,278,194 is how you would say that. All right, so on this number, we're going to identify the place value of each digit. And so I've listed these in the correct order. I always write it, whenever I write it, from the ones, and then I write the number to the left. And one number goes in each place value. All right, so we are looking for 7. 7 is right here. And so you would say that 7 belongs in the thousands. The 0 is in the 10,000s. The 1 is down here in the tens position. The 6 is right here in the 10 millions. And the 3 is right there in the millions place. Okay, now with really large numbers like this, I would have a tough time saying this without actually writing it in a place value chart. I mean, I could if I really thought about it, but again, I just think it's easier, especially if I have one sitting in front of me like I do right here. So the first thing I would do is I would fill in my chart. Okay, so how I would say this is I would say 8 trillion 165 billion 432 million 98. Notice I didn't say 098. All I said was 98,000 710. So that's how you say this. 8 trillion 165 billion 432 million 98,710. Okay, so rounding seems to be a big deal, and it shows up in every single class, and you really do need to know how to round appropriately. So I'm going to let you have a few seconds. You might want to hit pause, But please read through this page. I'm not going to read it to you, but read through this page and understand what each part means. And if you don't, talk to me about it. Okay, so on this page, we're going to round 103,978 to the nearest, on part A, the nearest 100. So according to these rules, and I've copied the rules and put them on this page as well, step 1 says locate the given place value and mark it with an arrow. So the hundreds place is right here. All digits to the left of the arrow do not change, so I know I'm going to have that for sure. Now, then it says underline the digit to the right of the given place value. So I'm going to underline this 7 here. Okay, so now this 7, because part 3 says is it greater than or equal to 5, so the answer is yes. So I add 1 to the digit in the given place value. So I have to add 1 right here to this 9. But look what happens whenever I add 1. That becomes 10, right? So I have to carry my 1. So actually this does become 104,000. And that's because this was a 9 right here. So I had to add 1 there and carry the 1. Okay, so now I'm going to erase and I'm going to start all over with the next problem. Alright, so the next problem says we're going to round this to the thousand place. So I'm going to locate the thousands place. It's right there. Underline the digit to the right. It's a 9. So nothing to the left changes, unless of course you have a 9 there and then you have to round up. But we don't. We have a 3 this time. So to the right of the 3 is 5 or greater. So you add 1 to the digit in the given place. So I'm going to add 1 to that 3. So look at that. When you round to the hundreds and on the thousands on this one, you actually get the same answer. And that's okay. Alright, so the last one, I'm going to round to the 10,000s place. Well here, oops, let me erase this. There we go. Here is our 10,000s place, the 0. Okay, so I know that the 1 stays put, and I look to the place immediately to the right. And because that's 4 or less, I don't change this at all. I don't round this guy up at all. And I just drop this. So I rounded to the nearest 10,000s place. Okay, on this page, we are just looking at the different multiples. So if you're looking for the multiples of 2, you can either read it from that column right there, or you can read it from this column right here. You get the same, except for the horizontal the horizontal row that goes out a little bit further. The vertical only goes to multiples of 10. So anyways, so you're looking at multiples of 2, 2, 4, 6, 8, 10, 12, 14, 16, so you're adding 2 to each one. Same thing goes if you count by 3s or 4s or 5s. If you're counting by 5s, you would add 5 to each one. So taking a look at this, your 2s are always even numbers. Check out your 4s. Those are also always even numbers. Your 3s, every other one is even, in case you've never thought about that. Your 5s always end in either 0 or 5. Your 6s are always even numbers. Your 7s, look at that, every other one is even. Your 8s, every single one is even. Your 9s, again, we're back to every other one. Your 10s always end in a 0. And look at your 11s. Every other one is even. And your 12s always even. This is not something you have to memorize. It's just something that maybe if you've never really thought about how numbers behave, this might be a good place to start thinking about that. Okay, so we have things called divisibility tests. And so it says here a number is divisible by 2 if the last digit is 0, 2, 4, 6, or 8. So if it's even, it's divisible by 3 if the sum means add, of the digits is divisible by 3. 5 if the last digit is 5 or 0. 6 if it's divisible by both 2 and 3. And 10 if it ends in a 0. Okay, so we are wondering about this right here, and I placed these rules, on this page so that we could remember them. Okay, so is 5,625 divisible by 2? Well, we can say no because the last digit is a 5, so it's not an even number. Now, I want to know if it's divisible by 3, so I have to add up the digits. 5 plus 6 plus 2 plus 5. 5 plus 6 is 11. 11 plus 2 is 13. 13 plus 5 is 18. So I would say yes, because 18 is a multiple of 3. And it's divisible by 3. Alright, so is it divisible by 5 if the last digit is 5 or 0? So the last digit is 5, so I would say yes on that one. Is it divisible by 6? It has to be divisible by both 2 and 3. And since it's not divisible by 2, I would say no on this one. It has to be divisible by both. And if it's divisible by 10 if it ends in a 0. And it does not end in a 0, so I would say no there. Alright, so this page right here is not a comprehensive list of all the prime and composite numbers, because certainly all of our numbers go past 19. This is just a short list telling you what numbers are prime and what numbers are composite. Now you might need a reminder of what is a prime number. A prime number is a counting number greater than 1 whose only factors are 1 and itself. A composite number is a counting number that is not prime. So a composite number has factors other than 1 and itself. And one thing I want you to notice here is that the only even number that is prime is 2. So 2 only has factors of 1 and itself, so it is considered prime. Take a look at 4. 4 has factors of 1, 2, and 4, so therefore it's composite. And every other even number after that is a composite number because it's divisible by 2. Now, the only numbers after 2 that are prime are really are odd numbers. So look at this. 3 is odd. 5 is also prime. 3 is prime. 5 is prime. Okay, 7, prime. Next prime number after that is going to be 11, also an odd number. Look at this, 13, also an odd number, that's prime. 17, odd number. 19, okay. So even numbers after 2 are never going to be prime. Odd numbers are only going to be the only primes that you have after the number, what? Actually starting with 3. I won't be asking you to remember this on a test or anything, but sometimes it comes up as to what is 1 and what is 0. Are those considered prime or composite? And actually those two numbers, 0 and 1, are in a special class of themselves called units, and they are neither prime nor composite. They're the only two numbers in our number system that are neither prime nor composite. Okay, so now we're going to talk about prime factorization. And whenever I talk about prime factorization, that means that I want a certain number written as a product. What does product mean? It means multiplication, a product of its prime numbers. And so in order to find that, so let's say that I'm asked to find the prime factorization of this thing. Here's how I do this. I write the number and then I start a number tree. And I look for prime numbers, and as soon as I find a prime number, I circle it. And so I ask myself, what two numbers multiply to be 48? And you can pick any two numbers that multiply to be 48. You can pick 2 and 24, and as soon as you come up with a prime number, circle it. Now from there, I want to see how 24, what two numbers multiply to be 24? You can come up with two numbers there too. What if I came up with 4 and 6? Neither one of those are prime. That's okay. Keep going. Now we're going to start a tree from there and there. So what two numbers multiply to be 4? 2 and 2. Oh, both of those are prime. And then on 6, 2 and 3. Both of those are prime. So once you have everything circled, then there's nothing else that you can factor. So 48 can be written as a product of 2 times 2 times 2 times 2. There's 4 of them. 1, 2, 3, 4 times 3. You could also write this in exponential form as 2 to the 4th power times 3. Now, what if in the beginning, we had done this? Let's say 6 times 8. That's also 48. Well, you would get 2 and 3 here. Those are both primes. 4 and 2, well, that one's prime. 2 and 2. Notice you still get the same answer. You get 4 2s and 1 3. So it still works out. No matter what two numbers you decide, just circle the primes as you get to them. Alright, so the least common multiple, the LCM, is the smallest number that is a multiple of both numbers. Okay, so here's a how-to. You list several multiples. This is my favorite way. Look for the smallest number that appears on both lists, and that number is your LCM. So using this method, if I want to find the least common multiple of 15 and 20, I list out the multiples of 15, 15, 30, 45, 60, 75, 90, and I'm going to list out the multiples of 20, 20, 40, 60, 80, 100, 120. Now what is the smallest number that they have in common? And it looks like it's 60. So the LCM of 15 and 20 is 60. Okay, so the way to find the LCM using the prime factors method, it's not my favorite way, but it is possible. I like the other way better. But you write each number as a product of primes and list the primes of each number, match the primes vertically when possible, bring down the columns, multiply the factors. I think that sounds very confusing and can get convoluted sometimes, but I'm going to show you how to do this. So if I want to find the LCM of 12 and 18, first I want to list them both as a product of primes. So 12 is equal to 2 times 2 times 3. I left a space there for a reason. You'll see it in a second. 18, 2 times 9, and 3 times 3. Okay, so 18 is 2 times 3 times 3. Okay, so you bring down the columns. So what I would do here, I would bring down that 2. I would only bring down, because these two match up, I only bring down one of those. These guys match up, so I would bring down one of these, and this doesn't have anything to match with, so I bring down one of those. So the LCM is 2 times 2 times 3 times 3. 2 times 2 is 4. 3 times 3 is 9. 4 times 9 is 36. So your LCM is 36. Alright, so I hope this helps out. If you're asked on your homework to find your LCM by this method or that method, I really don't care which method you choose, nor will I ask you on a test to use a specific method. So just make sure you do know how to find your LCM. It does come in handy in every math class that you're going to take after this class. So get used to it. Ask questions. Have a good day.